Hello, mic check. So a very good afternoon everyone. Welcome to the foundation course conducted by IMS GATE Academy. This is the course for strength of material and we are discussing all the basic concepts which are actually required to solve the application based question which was asked in examination. So today we will going to see one very important and one of the very basic topic, and that is how we apply functions or how we analyze any graph. Especially when I talk about the shear force and bending moment diagram, there is certain interrelation that we develop between shear force diagram and bending moment diagram. But due to we do not analyze the graph properly, we cannot interpret many concepts that are hidden inside that graph. So in order to analyze that, we will going to see the basics of graph theory today. Okay. So let's start with this. First of all, my dear students, can you tell me what do you understand by a function? Can you tell me what do you understand by a function, or what is the thing that means a function? Okay. So the first topic of discussion is what do you mean by a function? Okay. So for suppose we have a parameter x and this parameter is an independent parameter. We have a parameter x which is an independent parameter. Like I am giving you an example in terms of strength of material. Okay. If you have a body, you apply load over the body. Due to this load, deformations will happen over the body, right? So this deformation is an independent parameter. This deformation will not depend on any other thing. This deformation will directly happen over the body if you apply the load. Due to this deformation, there will be stresses produced in the body. So if I talk about an independent parameter, so strain is my independent parameter. Due to strain, stress will happen in the body. So my stress is a function of strain. So if x is an independent parameter, then function of x, this y will be my dependent parameter. Either you say parameter or you say variable, one of the same thing. Okay. So this x is an independent parameter. With changing value of x, you will get different value of y. So what we say, y is a function of x. For value of x1, if you substitute in this function, you will get y1 value of the function. For value x2, you will get y2 value of the function. For value x3, you will get y3 value of the function. So this x1, x2, x3 will be my independent parameter and the value of y will be dependent on the independent parameter, right? So this y is termed as the dependent parameter or the dependent variable. Now the relation between this y and x is termed as a function, right? If the value of y changes with the changing value of x, then we say that y is a function of x. Okay, so I think this is pretty much clear to us. From class 11th, we are studying functions and relation, and we exactly know the difference between function and relation. We need not to go into that depth, but first thing you should understand that if y is changing with the changing value of x, then y is the function of x, right? Okay. So I have a function y is equals to fx. Now this function can be of different varieties. This function can be either algebraic, This function can be either algebraic function. Example, if you write y is equals to, just for an example, if you write y is equals to ax square plus bx plus c. So this is just an example of an algebraic function. Algebraic function will always be continuous and differentiable function. They will be continuous throughout the domain in which they are defined, and they will be completely differentiable. So these algebraic functions are continuous functions and they are also differentiable functions. From the range x1 to x2 till they are defined, right? In this range where this algebraic function is defined, these functions will be both continuous and differentiable in their entire domain. So this is the domain of algebraic function. All this thing we have already seen in 11th or 12th class, but why we are seeing it again? Because these things will be required while we applying shear force and bending moment diagram, and also when we calculate the deflection using area moment method, right? So this is the first variety of function. Second variety of function is trigonometric functions. Second variety of function is the trigonometric function. Now if I talk about trigonometric function, it includes as y is equals to sin x, y is equals to sin x, or y is equals to cos x, or y is equals to sin x plus cos x. So anything related to this is a trigonometric function, right? For trigonometric function, we exactly need to check for the development of nodes. If any node or notch is developed, now what is a node or a notch? For suppose I am plotting any trigonometric function like this, right? So if this kind of node or notch is developed, where exactly there can be n number of slopes that exist. So at this point, your graph is not differentiable. Though it is continuous, but it is not differentiable if any notch is present. If any notch is present in a trigonometric graph, then at that point, your graph will not be differentiable. No doubt it is continuous because it is not showing any loss of point in between. That's why this graph is continuous, but we have to check for the differentiability of such kind of function. So trigonometric functions are no doubt. We need to check on the differentiability of the function, and we also need to check whether the functions are continuous or not. The third variety of functions are logarithmic functions. So if you write, for example, y is equals to natural log of x, or y is equals to e raised power x. Both these functions will be, first of all, continuous. Second, they will be differentiable in the range where these functions are defined. If you look into the curve of y is equals to natural log of x, you will have plot like this. So this is your y, this is your x-axis, and if you see the plot of natural log of x, it will be like this. Natural log of x is not defined for the negative value of x, and also when you tend towards 0, your value of natural log of x will tend towards negative infinity. Similarly, if you tend towards positive infinity, the value of natural log of x will also tend towards, or it will also keep on increasing. Okay. So this is how the function of logarithmic is defined. So logarithmic function, first of all, wherever it is defined, it is both continuous and it will be differentiable. So logarithmic function, it will be continuous and it will be differentiable in the entire domain where they will be defined. So wherever these functions are defined, in their entire domain, these functions will be continuous and these functions will be differentiable, right? Now, after reading about all these curves, the next type or the next differentiation between functions is, we have two varieties of functions. First one is the odd function. First one is the odd function. Now, what is an odd function? For suppose you have a curve like this, right? I'm telling you from the very basic how to identify odd function. For suppose you have a line y is equals to x. This is the function y is equals to x that you have. Okay. If your f of minus x is equals to minus of fx, then this function is said to be an odd function. We have already seen this definition for n number of times. Now, how exactly we can imagine what we mean by this? Okay. Just remove this part of the curve which is towards the negative x. Remove this part of the curve which is towards the negative x and focus on the part of the curve which is towards the positive x, right? So, in the positive range of x, you have a curve like this. What you have to do is, you have to keep a mirror like this, inclined at 45 degree in this way. Okay. If you get the mirror image on the other side, if you get the mirror image on the other side of the same function, then that function will be an odd function. What I said? Just concentrate on the positive side of the function, right? Keep a mirror inclined at 45 degrees to this origin in this fashion. If over this mirror you get an image of the curve, and if this image overlaps with the existing curve, then that function will be the odd function. As simple as that. So what do we mean by odd function? Odd function will be that function in which the mirror image, where for a mirror inclined at 45 degrees to the axis like this, is overlapping with the graph of the function for the negative value of x. So this will be your odd function, right? Next variety of function is your even function. Second variety of function is your even function. So odd function, this is the definition. Either you remember it like this or you remember in the fashion I told you. Keep the mirror like this. If you get the mirror image for this curve and this mirror image overlaps with the existing curve, then that curve is termed as an odd function. Now talking about the even function. The second variety of function is even function. So this is the curve of y is equals to mod x. Y is equals to mod x. Okay. If you look into the two components of the curve, this component is y is equals to x. This component is y is equals to x. And the other component is y is equals to minus x. These are the two components of the function y is equals to mod x. Now, how to check whether a function is an even function or not? According to definition, if f of minus x is equal to fx, then that function is termed as the even function. But practically, how to assure that whether a function is an even function or not? So it is again very simple. What you have to do, you have to keep the mirror straight along y-axis, right? If the mirror image overlaps with the existing curve, then that curve is termed as the even function. As simple as that. So either you check mathematically by saying f of minus x is equals to f of x, or you say, you place a mirror like this, and if you get the mirror image, and if this mirror image overlaps with the existing curve, then that function will be an even function. Most of the students have this confusion that how to define even and odd function. So I think this problem is also rectified, how to define even and odd function. Either you check mathematically for even function, or you check by placing the mirror. And I guess this kind of interrelation between even and odd function can help you define the function very easily. This year in GATE examination, in almost all the branches, a function was given to you. It was an aptitude question. A function was given to you, and I think not aptitude, some mathematics question. A function was given to you, and you need to identify whether that function was an odd function or even function. Like that, you have 4 options given to you. So this part of the graph theory can help you identify the functions, whether they are even functions or odd functions, right? So good afternoon, Thiru sir, a very good afternoon. Okay, so we are discussing about the graph theory and what are the basics. Okay, now moving on with this. Next is the slope of the curve. So if you have a curve like this is the curve y is equals to fx. First of all, what do we mean by the slope of the curve? The slope of the curve is, first of all, at any point, if you need to find out the slope, for suppose I need to find out the slope at this point. So what I will do, I'll draw a tangent at this point. I'll draw a tangent at this point, okay? Then with the horizontal, the angle made by the tangent will be some theta. So tan of this theta will be the slope at this point A. So if I need to write the slope of the function at point A, that slope is nothing but tan of angle theta made by the tangent at point A. And this theta is measured from the horizontal axis. So slope of the function at A slope of function at A is tan theta, and theta is the angle made by tangent with the horizontal. So this is the basic form of slope that we have. Okay, so this is some of the basic. Now we actually have one assumption, sir, the slope will change point to point due to the same function. Obviously, if you move on to the different points, you can have different tangents. So if you look into the different tangents at different points, say I need to find slope at point B. I need to find slope at point B. So if you draw the tangent like this at point B, this angle is obviously some other value than this angle, or I should say this theta dash will be more than theta. So with the changing value of the function, you will going to have the changing value of the slope. So this is very clear to us. So at different points, you have different value of the slope with respect to the function. How the function is defined, that will going to define how the slope is changing. So how to calculate this slope also? So if y is equals to fx is the function, then slope is dy by dx. Slope is dy by dx is the slope. And this is equal to f dash x. That is the first derivative of the function. So dy by dx is the slope of the function and dy by dx is the first derivative of x. Okay. Now moving to a very close point why we have discussed all this. Actually, in most of the cases, we say that since theta is very small, since theta is very small, so sine theta is equal to tan theta is equal to theta. Okay. Now how this comes? This is the main agenda why we are discussing this graph theory. Okay. So first of all, if you see the graph of sine theta, tan theta, and so I'll draw this graph of all this thing. Okay, so this is my x-axis. This is my minus x-axis. This is plus x-axis. This is plus y-axis, and this is minus y-axis. Just observe this. If I draw the sine function, so sine function is like this. This is my sine theta. Like this is my sine curve. So this is my sine theta, right? At x is equals to 0, this is my x is equals to 0. The value of sine theta is also 0. And if you check with the slope of sine curve at theta is equals to 0, this slope is 1. If you check with this slope, if you check with this slope of the curve, right, that is the slope of sine theta at 0, you will find that this angle is 45 degrees. This angle is 45 degrees. And how I am saying this? As we know that d by dx of sine theta or d by d theta of sine theta is equal to cos theta, and cos theta at 0 degree is 1. Okay. Cos theta at 0 degree is 1. Therefore, the slope of sine theta at 0 degree is also 1. Similarly, if I draw the function y is equals to tan theta. So this is sine theta. This is the function of sine theta. Next, I will draw the function for tan theta. So this is the function y is equals to tan theta. And y is equals to tan theta is again defined in the range of minus pi by 2 to plus pi by 2. It is defined in this cycle only, right? For the next cycle, again you took from pi by 2 to 3 pi by 2. Like that, your function for tan theta is defined. And even if you look for the slope of this tan theta, so d by d theta of tan theta is d by d theta of tan theta is sec square theta, and sec square theta at 0 degree is also 1, right? So for both this curve sin theta and tan theta at 0 degree, both of them have the same slope, okay? And also at 0 degree, both sin theta and tan theta has the value equal to 0. Now understand this. What do we mean by when theta is very small? We does not mean that theta is equal to 0. If we write this, theta is very small, we does not mean that theta is equal to 0. What we mean is this theta is very close to 0, means we are talking about this vicinity. We are talking about this value of theta. We are so close to 0 that theta is very small. And when you look into this thing, you will find that at 0 degree or around 0 degree, both of these curves, sin theta and tan theta, overlaps each other. And if two curves overlaps each other, it means that both of them have the same value of the function. So if theta is very small, your sin theta and tan theta overlaps each other. And if I consider this also as a curve, this is nothing but y is equals to theta. This curve is y is equals to theta, which also represents the slope of sin theta and tan theta at 0 degrees. Okay. So if you observe this carefully, three of these curves, sin theta, tan theta and theta, are overlapping each other at the vicinity of the theta. Means that theta is very small. The value of sin theta will be equal to tan theta will be equal to theta. So either of them can be used if theta is very small. If theta is very small, then either of them can be used. So as per your convenience, you can interchange sin theta with tan theta or tan theta with theta, right? So this is totally dependent on you. So this is the thing for less value of theta. Okay, so this is the one part of the curve. Moving on to the another part. For suppose you have a function like this, right? This is the function y is equals to fx. Now we need to say something about the slope of this function, okay? So if you look at this point, right, this is the tangent that we have at this point, and the angle made by the tangent with the horizontal is something like this. This is the angle made by the tangent. So this is theta. At this point, this will be my tangent, and now the angle made is some theta dash. So you can clearly observe that, say this is negative theta, not minus theta, and this is minus theta dash, right? So you can clearly observe that when the function is moving in this direction, okay, the slope is also increasing. We can clearly identify that minus theta is less than minus theta dash. So the slope is increasing from minus theta to minus theta dash, right? So this is the curve where the slope is increasing from minus theta to minus theta dash. So for this curve, slope is increasing from minus theta to minus theta dash. Similarly, if you have a function like this, right? So at this point, you have this slope. Theta, right? At this point, you have this slope. This is theta dash. And now the slope is decreasing from theta to theta dash. So this you need to identify by looking into the function whether the slope is increasing or whether the slope is decreasing. So for this function, the slope is decreasing from theta to theta dash. So slope is decreasing from theta to theta dash, right? Now, why I am telling you this is, when we discuss about shear force and bending moment diagram, usually we need to interpret between these two diagrams. The shear force diagram is the derivative of the bending moment diagram, okay? So we need to check the slope of the bending moment diagram, and the slope of the bending moment diagram will going to tell us about the shear force diagram. So in that analysis, we require this part. So for any curve, if your theta is decreasing from theta to theta dash, we say this, your slope is decreasing for the curve. And on this side, where the theta is increasing from minus theta to minus theta dash, we say that the slope is increasing, okay? So when we need to define the interrelation between two graphs, the only thing that we can do is, we can have the relation between the slopes, and through that slope, we can explain that, okay? Now moving on to the last part of this, there are certain figures for which we should know the area and their position of CG. These three things should be known, right? So first I'll start with the simple figure square. So square with side A and A. CG located at this point, and this position is X bar. I'll write down only X bar, right? X bar is the position of their CG. So area for this figure is A square, simple. CG is A by 2. Okay. Moving on, next one is rectangle. This side is A, this side is B, and this is the position of CG, X bar. Area is AB and CG is B by 2. Next one is your triangle. Base is B and height is H. This is the position of CG, and this CG is Y bar. Area is half base into height. Area is half base into height. Then your CG will be Y bar is equals to 2H by 3. 2H by 3 from the top. So this will be H by 3 from the base. So y bar is 2h by 3. Next is your trapezium. This side is A, this is B, this height is h. The position of CG is y bar from the base. So for trapezium, area is h by 2 into A plus B. This is the area. If I talk about the CG y bar is simple. It is equal to h by 3, right? You have to remember h by 3. Now for calculating y bar, we are moving from B to A. So while moving from B to A, you will write 2A plus B by A plus B. So this is the CG for your trapezium. You can note this down. Next is your parabolic spandrel. This is your parabolic spandrel. So this side is A, this side is B. This is parabolic. CG is somewhere here. So this is your x bar. So for this kind of figure, if you need to calculate the area, it is very easy. So area is 2/3 of A into B. Simple. 2/3 of A into B. And this x bar is 5B by 8. This x bar is 5B by 8. So when you have this convex shape of the figure, for this convex shape, area is 2/3 of A into B and x bar is 5B by 8. But when you have this concave shape of the figure, this is the concave shape. So this is A and this is B. This is the concave shape of the figure. For this concave shape, this is my x bar. For this concave shape of the figure, area is 1/3 of A into B. So when you have this concave shape, and this is also parabolic spandrel, but this is convex shape and this is concave shape, right? This is bulging outward, bulging inward. Area is 1/3 of A into B and x bar is 3B by 4. X bar is 3B by 4. Just observe which end I am talking about. I have always taken the end which have less value of the function or where the function is getting merged. Okay. From that end, the value of x bar can be calculated. So these are some common things that are actually required for area moment method and also for drawing the SFD and BMD. Okay, so I hope these basics are clear to you. You might have seen a lot of new things in this session we have also discussed whatever you already know and whatever you have already learned in the 11th or 12th class. In the next session, we will start with the shear force and the bending moment diagram, and we will see the basics how to draw these two diagrams. So that is all for the day. Thank you so much for listening patiently. I'll see you in the next session. Have a good day.